Hi everyone, it's 𝗦𝗲𝗀𝗀𝗀𝗀 here, CTO at Nasstar. If you've seen our introduction video, you will have heard me speak about the importance of thought leadership and how this can impact the businesses that we work for. What follows shortly is a demonstration of how applying thought leadership to a business problem and developing an AI-based solution can solve a specific business problem. Firstly, a little bit about us. Nasstar was a traditional managed service and hosting provider with the twist of having a large telecommunications business in the mix. Recently, we made the strategic decision to pivot our hosting business to public cloud and decommission most of our private cloud hosted data centers with a view of doing all of this hosting in Microsoft Azure. In parallel, we have also built a set of next-generation managed services, which are cloud-centric in nature and span connectivity, data center hosting, and workplace services. Our goal is to be a leading Microsoft partner for SMC and early enterprise businesses, want to future-proof their infrastructure, and more importantly, go on to empower their workforce, automate business processes, and build digital experiences. In 2023, we purchased Colibri Digital to add strong data and AI services to our portfolio. Colibri has brought to the Nasstar family a wealth of experience delivering modern data platforms on technologies like Databricks and more recently, Microsoft Fabric. Since welcoming the team to the business, we are now able to lead with compelling AI use cases alongside their data science and engineering capability. What follows is a demo of a customer use case that shows off some of our capabilities in the AI and data space. The customer in question is a public sector transport organization. They had an existing manual process that received documents from the public, which were processed for the purposes of registering for a toll system recently deployed. Increases in demand for this service was going to drive 300 additional heads to process these registrations, and our customer wanted to automate this manual document processing function with AI. I'll hand over to Andrea now to take you through the demo.
Hello everyone, my name is Andrea Rosales and I'm a lead data scientist at Colibri Digital. Today we're diving into a challenge that many organizations face, managing the overwhelming volume of documents while ensuring accurate and efficient data extraction. First, I'm going to give a bit of a background to understand why this solution is important. Then I will explain the three main features of our solution and the benefits. So let's start. Many organizations handle large volumes of documents, whether processing mortgage or employment applications or handling legal paperwork. The need for accurate and efficient data extraction is critical. Traditionally, this process has been manual, requiring significant human effort which can lead to mistake or overlooked errors. To address these challenges, we have developed an advanced AI solution that automates the extraction, processing, and verification of data from different document formats and structures. Our solution has three main features. The first one is the data validation, where we cross-verify the extracted data from the document with the user inputs during the registration process to ensure accuracy. The second feature is the quality assessment, where we evaluate the quality of the documents in terms of contrast and blurriness to ensure an accurate extraction. And the third feature is the fraud detection, where we verify the authenticity of the document and detect any modification or fraudulent alterations. Like I said, our solution offers many advantages for businesses, including cost saving, operational efficiency, and scalability. So how it works? Here is a general overview of our process flow. So we start with our input data. In this case, for this demo, we're going to process one document at a time, and we're going to be handling proof of addresses. So first, we extract the content of the document using Microsoft Document Intelligence. Microsoft Document Intelligence incorporates multiple AI tools for document understanding and data extraction. So for our solution, we use the pre-trained layout LM model that incorporates the spatial layout of documents to recognize text, tables, images, and other elements in the document. This capability is particularly beneficial for processing documents with complex formats. Once the content has been extracted, we use a large language model from Azure OpenAI. In this case, we are using a GPT model which are highly effective in extracting the information from text. For this demo, we will extract the name from the user, the address and postcode, and the date of issue of the document. We also ask our AI model to classify the document based on its content. So like I said, we are handling proof of address document. So the categories are going to be utility bills, bank statement, council tax bills, and vehicle registration. Then we have a confirmation step where we ensure that the entities extracted in the previous step align with the user information. If there are any discrepancy or missing data, we can correct them at this stage. And finally, we have our output. So let me go to the demo and show you how the solution works. So for the demo, we use synthetic documents to protect a user's personal private information, but the format of the documents are representative of the real ones. So first, I'm going to show you how the document processing works. I'm going to upload a document. This is going to be a proof of address, and I'm going to upload a bank statement. When we click Analyze, we can see the different steps. So first, we are connecting to Document Intelligence to extract the content. Then we connect to Azure OpenAI to extract the entities that we need, and we run our confirmation step. The first thing that we are going to see is the document itself, so that we can analyze the layout of the document. Here on top, we have the date of issue of the document, which is 28th of February 2024. This bank statement corresponds to Maria Potter. Here we have the address. And as we can see, this document contains multiple dates. Here we have the period for which this bank statement is valid. If we see the output of our AI engine, we can see that this document has been classified correctly as a bank statement, and the name, address, and postcode corresponds to the user, and the same that we can see in the document. And the date of issue is the 28th of February 2024. I'll show another example of a council tax statement, which has a more complex format. So again, when we click Analyze, we can see the different steps. We connect to Document Intelligence, we extract the content, then we connect to Azure OpenAI, we extract the entities that we need, we run our confirmation step, and our task is complete. So as we can see, this document contains multiple addresses. The first one corresponds to the City of Edinburgh Council. And then we have the user details. We have the user details here on top of left, but we also have the properties details on the top right. The date of issue of this document is 12th of March 2024, but this document also contains multiple dates corresponding to the tax financial year and the period for which this council tax statement is valid. However, when we see the output of our AI engine, we can see that the document has been classified correctly as a council tax, and all the user details are correct, and the date of document is 12th of March 2024. So now I'm going to simulate a registration process where a user will provide their details. I have already written some of this information, the name, address, and postcode of a user. The registration data has been saved successfully. So then I'm going to provide a proof of address. So I'm going to upload the bank statement that we saw previously. So we're going to see how our engine works by extracting the content, extracting the entities that we need, validating that the information actually corresponds to the user. And yeah, like we see here, we have the output of our AI engine. And when we go to the verification step, here is where we validate that the information extracted from the user actually corresponds to the input data provided by the user. So in this case, we have different matching scores. Here we can see in the address that the match score is 96%. This is because the address can be written in different ways, but we provide an overall matching score. In this case, is 98%. So if the matching score is lower than a threshold, for example, 18%, this can raise an error or a rejection, or I can human validate the application process, or maybe we can ask the user to provide other proof of address if we think that the entities don't match. So this part corresponds to the data processing. Now I'm going to continue to the fraud checks. So while I explain the checks that we have implemented, I'm going to start processing one of the PDFs documents. In this PDF, what I did, I modified the original dates that are 2023 to 2024. So we have implemented 3 checks to verify the authenticity of the documents. So the first one is the anomaly in the metadata. So we search for any anomalies in the creation or modification date, creation software, overwritten or deleted metadata, editing tools, document history, and so on. The second check is what we call the X-ray analysis to detect hidden text. So this technique is particularly useful for uncovering modification where new text or images have been placed on top of the original content. And the final check is the error level analysis. This is a forensic technique used to detect inconsistencies in images, which can indicate a potential manipulation. So the idea is that all the elements that are original from the image are going to compress at the same rate, while everything that has been added or any additions to the documents are going to have different compression rates. And this is where we can suspect if the document has been modified or not. So here first I have the results of my fraud checks for this PDF. And we can see a warning in the metadata because it hasn't found important keys in the metadata, like creation dates or creation softwares. The error level analysis has passed. However, in the X-ray analysis, it has detected that there is a hidden text. So if I go here, it has identified that the hidden text is 2023 and the text on top is 2024. So we also provide visual evidence. So in this case, we provide the document itself and we highlighted the areas where the hidden text was found. Now I'm going to process another document to show you how the error level analysis work. So for this, I'm going to upload a utility bill where I have modified the last 3 characters of the postcode. So we are processing our document and we will see the output of our checks. So here the metadata check has passed. However, the error level analysis has failed. So if we go to the visual evidence, we provide different heat maps to see the different compression levels. But I'm going to explain the last 2 here at the bottom to show you the different compression rates. So like I explained before, all the elements that are original from the image are going to compress at the same rate, while everything that has been added or edited in the document are going to compress at different rate. So here in this image, we can see the user details, all this area of the user details, the name, address, and the 3 first characters of the postcode compress at the same rate, while the last 3 characters of the postcode have different compression rate and we cannot see them. This is also very visible in this heat map where we analyze the blurriness, that is any change in font, and we can see that the last 3 characters of the postcode are more bright than the rest of the elements. Right? I'm going to process another document to show other editions. This is a vehicle registration. And this vehicle registration has been edited using Photoshop, and this is going to be detected by our metadata check. So when we expand and see the reasons why it has failed, it tells us that it has been edited using Adobe Photoshop. And of course, the error level analysis has also failed because it has found the areas where it has edited. When we go to the visual evidence, we have these heat maps, and the edition in this document is where the user details are and where the vehicle reference number is located. So we can see that we have very bright areas in the document, which show the areas where the edition happened. Also here in this case, the noise is inconsistent, especially in this area where the reference number is located. So the goal is that with all these techniques combined, we can provide guidance whether or not the document has been edited or not. So I hope you enjoyed this demo, and I also hope you find this tool very useful. Thank you.
Well, I hope you found that demo interesting, and maybe it's prompted some ideas for you and your business where you may have a similar use case. So just in closing about us, Nasstar has partner designations in data and AI on Azure, digital and app innovation, modern work, infrastructure, and security. We are a fast-track partner for Azure and M365 and can leverage the AM program for migrating and modernizing workloads on Azure. Being a Microsoft partner, we have access to a large range of funded workshops. So please get in touch with us to discuss how Nasstar can partner with you on your AI transformation journey. Many thanks.